Here we are for Honors Physics, Universal Gravitation, Worksheet 3, Problem 6. All right, and Problem 6 is very similar to the previous one, Problem 5. We're looking at gravity on Mars. But this time what they're asking specifically for is what I kind of feel like they should have asked before, and that's what's the value for G on Mars? That's the acceleration due to gravity, or the gravitational field strength on Mars' surface if Mars has this mass and this radius. And if you compare with Problem 5, you'll see that the values, I mean, they're just more precise in this one. We just gave you nicer numbers to work with on this problem. No particular reason, I guess. I don't know. Anyway, but we can go ahead and we can calculate this out. What we're trying to find is the acceleration due to gravity. So it's as if, it's exactly as if, we say, look, here's Mars. And we're going to drop an object at the surface. And we're going to let it fall. Now, if I have this falling object, the only force acting on it is the gravitational force. So I could use sigma F equals ma for that falling object. If a falling object, then the only force is gravity. And that acceleration is the acceleration due to gravity. Now, on Mars, that's a different value than 9.8. 9.8 is what is the surface of the Earth. So I'm just going to call that G Mars. That's the thing I'm trying to solve for. This is the mass of the thing that's falling. Let's use the cool new gravity formula here. So if we substitute that in, we would have big G, and then the masses of the two objects. So I don't know, just call it mass of object and mass of Mars divided by, now what about this distance? So that's the distance between the middles, the middle of Mars and the middle of that object we're dropping. Now if we're dropping that at the surface, pretty much that's then that distance between the middles, that's just the radius of the planet. Okay, so that's just the radius of Mars, right? Is that distance between the middle of the planet to the surface. And then this m, what's the object that we're accelerating here? The object that we're dropping, right? And so this is the mass of the object on this side. And then G Mars. Okay, why did I change colors? I don't know. I guess black shows up probably better. So here we go. You'll notice right away that in this calculation, what's going to drop out? Mass of the object drops out. And that means any object would fall with the same acceleration at the surface of Mars, right? Because that's the same thing as on Earth, right? You drop an object, all objects fall with the same constant acceleration. That's called Galileo's law of falling bodies, right? Every object falls with the same constant acceleration. This is kind of a why. You say, well, look, if I had, say, twice the mass, then from F is ma, I would have twice the inertia. It's twice as hard to accelerate me. But from universal gravitation, if I have twice the mass, gravity pulls twice as hard. So it perfectly balances out. You make a bigger object, it's okay, gravity pulls on it more, and it perfectly balances out every time. And so the mass of the object doesn't affect the acceleration due to gravity. Right? So that's the deal there. So we can now we're trying to find G Mars. We have G Mars by itself now. We can just plug in our values here. Big G, mass of the planet, divided by the radius of the planet squared. Punching in my values, 6.67 times 10 to the negative 11. The mass of Mars, they gave us a value this time of 6.4171 times 10 to the 23rd kilograms. And we're going to divide by the radius of the planet, which this time they give us a little bit more precise value, 3,396,200. 3,396,200. That would be that. All right, and then we're going to square it because the formula says square it. That's it, right? That's going to be G Mars. So now I'll just punch it in my calculator. You know the way I'm going to do it. You know I'm going to do 6.67 times the 6.4171 divided by 3.3962 squared, and then I'll resolve the powers of 10 myself. The powers of 10, 10 to the negative 11, 10 to the 23rd, that'd be 10 to the 12. 10 to the 6 squared would be 10 to the 12. 10 to the 12 would be 10 to the 12. That's just going to be 1. So really it's just going to be 6.67 times 6.4171 divided by 3.3962. Punching that in my calculator. 6.4171 divided by 3.3962 squared. And I get a value of 3.71. Okay, so that is G on Mars is 3.71 meters per second squared. right? And so that's significantly less than the acceleration due to gravity on Earth, so objects would fall more slowly, right? Good enough, good enough. Okay, and the planet pulls down less hard. Yep, that's the deal.